I wanted to do a second video about mixture problems that talks about an intuitive way to think about them as an averaging, as a weighted average of the low rate and the high rate. So let's start with some examples. So let's suppose we have this problem here. Of the 4,000 full-time students, 20% of that population was surveyed, and of 2,000 people in a different population, 10% of that group, 10% of the part-time students were surveyed. So when you combine the students into the whole student body, what percentage overall was surveyed? That's the question. And so you can set this up like we did before with the 6 parentheses, and this many students at this rate and this many students at this rate combines to give you 6,000 students at some unknown rate. We don't know what it is. And if you do the calculations, the 20% of the 4,000 is 800, 10% of the 2,000 is 200, and you solve and you get x equals 1/6. So 1/6 of the overall student population, or 16.67%, was surveyed. Fair enough. Let's do a similar problem with change the numbers a little bit. So now we've got evenly balanced. Of the 6,000 students, let's pretend 3,000 were full-time and 3,000 were part-time. And the full-time are again at 20% surveyed, and the part-time are again at 10% surveyed. So now we have two groups that are mixed, but we've got an equal amount of the low rate and the equal amount of the high rate. So we've got equal amount at 10% and equal amount at 20%. And it comes out to halfway between the low and the high at 15%, halfway between 10% and 20%. Let's see if that pattern continues. What if we had some different values? Let's say we had 5,400 at the high rate and 600 at the low rate. We calculate that, we get 19% of the overall. So now we've got all three of these situations. Depending on what the proportions of the low rate and the high rate were, we get different values for the overall mixture percentage, right? And I want to see if we can find a pattern in there. And in some cases, we're going to be able to do this at least a little bit intuitively if the numbers work out nicely. So this is a little messy, a little bit over the top, but let's see. In the first case, we've got, let's pick a different color here, blue. Of the 6,000 students, 2/3 were at the higher rate. And so what that means is we've kind of gone from 10 to 20. The low is 10 and the high is 20. If 2/3 are on the high side, we've gone 2/3 of the way across to 16 and 16.7. What about in the second case, where we've got half the people at the high rate and half the people at the low rate? Well, our overall estimate, our overall average, is halfway between the low and the high. What if we have, in the last case, we had 5,400 out of the 6,000 students? That's 90% at the high rate, right? 90% of 6,000 is 5,400. And so we've gone 90% of the way from 10% up to 20%. So we've gone from 10 to 20, a low rate of 10 to a high rate of 20. 90% of the way over there is 19, from 10 to 20. So let's see if we can graph that and get a sense of how that works too. It turns out you can come up with a little formula, a nice linear equation, if your variable is P, the percent of people at the high rate. So if you're mixing two things, you've got some at a high rate and some at a low rate. And it could be a percent, it could be a high cost, like we did dollars per pound, it could be a high concentration, like grams per liter, whatever. Got a high rate and a low rate. Let P be the percent of things at the high rate, and then 100 minus P is the percent at the low rate, and 100 is the total. And so we can get this formula, this nice equation here, where P is the variable and X is the output, right? It'll tell us the final mixed rate. And so it comes out to this little chart, and we have, on the horizontal axis, we have the percent at the higher rate from 0 to 100. And on the vertical axis, we have in this case, the percent of the mixture, the mixture percent. And when we have nobody at the higher rate, we're down here at 10% because that's everybody's at the low rate. What if we're at the other side where we've got 100% at the high rate, then we're at 20. And that's a linear equation we've got circled in blue at the top. And so the line goes straight like this. Halfway between 50 or 0 and 100, our y value is going to be halfway between the low and the high. Or let me make that high actually go across to the high. The low value and the high value, the high rate. And so in our case where we were 2/3 of the way, 2/3 of the students were at the high rate, then our average is going to be 2/3 of the way from 10 to 20, which is up to 16.7. At 90%, our average is going to be 90% of the way up here. If this is 10, then that 90% is just 9. If the difference between the low and the high is 10, 90% of the way up is up 9 above the low value, which is to 19. If that makes sense, great. If it doesn't, that's okay. You can always just solve the algebra, but this is an interesting kind of intuitive way to look at it, particularly when the numbers come out nicely and the ratios come out nicely. So let me do a couple examples where it works out nicely. And so here's that example we did in the previous video where we have 500 people and they are surveyed at 20%, or the 20% agree with the survey, or whatever the problem was. And we have another group of people at 35%, and the average or the mixture is 30%. So the low in this case is 20%. That's the low rate. The high rate is 35%. And so there's 15% between them, right? It can go up 15 percentage points. And what we've got is in our mixture over here, we've got 30%. So 30% is right here. Let me switch colors. 30% is here. And at that height, we're 2/3 of the way up. So we go 2/3 of the way over, and 2/3 of the people are at the higher rate. Right? So 30% is, let's say, it's up 10, which is 2/3 of the 15 from the low to the high. Oops. So if you can visualize that, in this case, we've got a 15 percentage point difference between the low and the high. And if we've mixed it and we've gone from 20 up to 30, which is 2/3 of the way to the high, then that means we have 2/3 of the people are in the high group. If you can see that and see the form, so if the fractions work out nicely, the proportions work out nicely, that works. If this is over too much, and in a lot of cases this doesn't work because the fractions don't work out nicely, but it's a nice intuition. Here's another example we did in the previous video with percentages of the solution of 3 grams per liter saline solution, and you mix it with a high rate solution. So we don't know what the high rate is, and we know we end up at 10% or 10 grams per liter. And so, but we do know nice fractions. We've got 1 out of the 300, so 1/3 is at the low rate and 2/3 is at the high rate. So we know from our low rate of 3, we don't know what the high rate is yet, so we'll leave that as a question mark. But 2/3 of the way across, we get up to a height of 10. So 2/3 increase goes from 3 to 10. So the remaining 1/3 is half of that, which is 3.5. So we go up to a final value of 13.5. And so it might be easier in a lot of cases to just do the calculations, but a lot of times if it works out to be a nice proportion, this is an easy way, and we'll do some examples in class where you can look at this, and if you think about the proportions correctly, and if you're a little lucky that the numbers come out nice, you can do this in your head.